Okay, good morning, grade 8 to 9. So we're going to quickly do a little space and shape summary, and then you're going to get a whole little sort of potty pack for the last week of quarantine where I've indicated each day what it is that I want you to do, what questions I want you to do. It's all past paper questions, so it's good practice. Okay, so these are the four main areas that we looked at under space and shape. So we looked at Pythagoras, area and perimeter, composite shapes, and then prisms. So prisms, remember, that was for volume and total surface area of our 3D shapes. That's what our prisms are. Okay, so starting with Pythagoras, a quick reminder of this. Pythagoras is, remember, it's a way to determine the length of the third side of a triangle if we know two sides and if our triangle is a right angle triangle. So firstly, just in terms of sort of analyzing and understanding our triangle, if we have a right angle triangle, I'm purposefully drawing it a little bit upside down this time because it can be like that. So if we have a right angle triangle, then the side opposite our 90 degree, so that side there, is called our hypotenuse. Okay, a reminder, the hypotenuse is also the longest side. It will always be the longest side. Sorry about the squeaking, I won't use this one for long. Okay, so Pythagoras' theorem talks about right angle triangles, and in the right angle triangle you must be able to identify the hypotenuse. And then with Pythagoras' theorem, what it says is that the length of the hypotenuse squared is equal to the sum of the lengths of the other two sides squared. And also remember, with Pythagoras you need a reason, and your reason is Pythag. Every time you use Pythagoras to solve a problem, you have to put Pythag in brackets there. Okay, and that is Pythagoras' theorem in a nutshell. That's it. Okay, that cookie doesn't work. Okay, so Pythagoras' theorem in a nutshell. Obviously, you've seen there's quite a lot more to it. You could get scenarios where you've got two triangles stuck together. You might have to use Pythagoras as a step towards something else, but in a little nutshell, that's Pythag. Okay, then next up we looked at area and perimeter. So for area and perimeter, the most important thing here is to know your formulae. You should by now know them all off by heart. So for this, you should be able to actually just close your eyes and write this section yourself without me doing it in the video, but I'm going to do it anyway in case we forgot. So we're going to look at, let's first look at the square. Okay, so formulae. For the square, the area of a square is equal to side times side, or side squared. And the perimeter of a square is equal to 4 times the side length. Okay, next up, let's look at a rectangle. Okay, for rectangle, area is equal to length times breadth, and perimeter is equal to 2 times length plus 2 times breadth, or 2 times length plus breadth. Okay, so for a square, there's two different ways to find the area. They really technically mean the same thing, and for a rectangle, there's two ways to find the perimeter. Again, it means the same thing. I will give you the same answer. Okay, next up, we're going to look at, what's the next one I wanted to do? Triangle. We're going to do circle last. Okay, so triangle. Okay, so area for a triangle is half times base times height. And now quickly a little important note about the base and the height. These are the sides that form a 90-degree angle. Okay, and then the perimeter of our triangle is just the sum of the three sides. And then lastly, our circle. Okay, if we have a normal circle, then the area is equal to pi times radius squared, and the circumference, which is the fancy word we use for perimeter of a circle, is equal to 2 times pi times radius. And a little note to self about this, radius is equal to diameter divided by 2. Okay, then if you've got a fraction of a circle, okay, if you have a fraction of a circle, then remember all you have to do is put that fraction in front of your formula there. Okay, so if we have half a circle, the area would be half times pi times r squared. If we had a quarter of a circle, it would be a quarter times pi times r squared. Okay, so if you have a fraction of a circle, your area is equal to the fraction times pi times radius squared. Okay, and that is area and perimeter in a nutshell. Okay, so you do need to please make sure you know these formulae and you know how to deal with a scenario where, for example, the diameter is given instead of the radius, or where you have a fraction of a circle, or with triangles. Remember, we saw a few where we had alarasis, but remember we saw some where there was no right angle in the triangle, but you could form one by drawing in the perpendicular height. Or there was that one that was sort of leaning backwards. Okay, where this would be your base, and your perpendicular height is the distance from the apex to the horizontal. So there's your right angle there. So that would be your H, and this solid line would be your base. Okay. Then next up we looked at composite shapes. So for composite shapes, not necessarily formula that you need to learn, rather methods that you need to learn. So there's different methods. There's a method for the area, and then there's a completely different method for perimeter. Okay, so I'm going to look first at area. Okay, so to determine the area of a composite shape, 1, you find the area of each part. Okay, so if our shape is made up of a rectangle and a triangle and a half a circle, you find the area of your rectangle, your triangle, and your half a circle using these formulae here. Okay, using this. Okay, then when you've got the area of each part, you add together or subtract. Okay, so you add together if it's been stuck together, or subtract if something's been cut out. Okay, and that is basically it for area. Then for perimeter, completely different method. Okay, please do not even think about area and perimeter are completely unrelated. Do not get them mixed up. So for perimeter, you find the outside edge lengths. Okay, so we basically, with perimeter, we want to know if I were to walk around the outside lines of this shape, how far would I be walking? Okay, so if you can find how long each of the sides is, and then you add them together, you've got the perimeter. Okay, so note that for perimeter, we add always. For area, sometimes we might add, sometimes we might subtract. Okay, and that's it for composite shapes. Okay, then lastly, prisms. So with prisms, we've got two formulae. We've got we've got volume, and we've got total surface area. So here are our two formulae. So volume of a prism is equal to the area of its base multiplied by the height of the prism. Okay, and the total surface area of a prism is calculated by saying 2 times the area of the base plus the perimeter of the base times height. Now, if your prism is a nice normal prism, by normal I mean it's got a base that's a square, a rectangle, a triangle, or a circle, then from here you would expand, so you would rewrite this formula, but instead of area of base, you would write the formula for whatever your base is. So let's say it's a square, we would rewrite this, but instead of a base, we would put side times side, and then substitute, and then solve. Okay, so if it's a nice normal shape, you expand, substitute, solve. So I'm going to write that here. Okay, so if it's a normal, in inverted commas, okay, then you're going to expand, then substitute, okay, and then solve. That's all there is to it if it's a, quote, normal prism. If it's an abnormal prism, i.e. your base might be a composite shape. Okay, so if we have a composite based prism, Okay, it's not that hard. You will individually determine the area and the perimeter using this method and then substitute those values into your formula. Okay, so you find area and perimeter according to that method, and then you will substitute and then solve. Okay, so instead of expanding the formula, expanding that to be what the formula of the base of a square is, or a rectangle or a triangle, you will rather separately do a little calculation using this method here for the composite shaped base, and then substitute your values straight into your formula and solve. Okay, and I am done. That's it. Okay, then I just want to quickly look at a few other little sort of helpful tips and tricks, mainly just unit conversions. Okay, so I know quite a few of us were a little bit confused with converting units. Okay, so it's usually in terms of the volume. Oh, actually, let's just look. Okay, so area is always in units. Let's just say units instead of meters. Area is always in units squared. Perimeter is always just plain units. Total surface area is in units squared again, and volume is always in units cubed. So if you're given your dimensions in meters, then this would be meters cubed, this would be meters squared, etc. Now in terms of some conversions, the biggest one I'm really seeing people struggle with is the volume stuff. So milliliters to liters, okay, if you want to convert from milliliters to liters, you will divide by 1,000. Okay, so if you've got 100 milliliters, you divide by 1,000, it'll tell you how many liters you have. Okay, and if you want to go the other way, you would multiply by 1,000. So if you've got liters and you want milliliters, you'd times by 1,000. Then the next one is usually when we calculate volume, it's going to be in millimeters cubed or centimeters cubed or meters cubed. And they'll often ask you to convert that into liters or milliliters. Okay, so I'm going to just show you from meters cubed to liters. And I'm hoping some of you are planning on doing physical sciences in grade 10. This is going to come in very handy then. We'll show you all the unit conversions then. But for now, meters cubed to liters. Meter cubed is 1,000 decimeters cubed, so you will multiply by 1,000. Okay, so for now I think that should be the only unit conversions you might need come test or an exam. If there's anything else, they will probably give you how to convert in the question. Okay, yeah, so that's basically it. If you're stuck with anything, please do ask, because this is it. I'm not teaching any more space and shape. I'm going to give you your past paper questions to do. I think there's about 4 or 5 days worth. And then we are going to do a little online quiz so I can make sure you're all up to date and you are understanding and you have been following and actually doing some maths during this period. Okay, so yeah, let me know if you're stuck. I'm here to help, and hopefully we can all see each other soon.